Recording. Right.
All right, finally, nice to finally meet you guys in person. I know we've been having some back and forth. It's a real quick question. We have Gabriel on this as well. Oh, I see him. There he is joining.
Yeah, I'm on here.
Okay, awesome. So obviously we're not meeting Monday. We're meeting now. If you saw my email.
All
Okay.
right, roger that.
So I just have a couple questions. The biggest thing I want to ask before we get started with the walkthrough of the rocket, hopefully you guys have the rocket available or at least can speak to some of it, is the 4 questions I kind of posted there in the chat. So when I looked at your last report, the last 2 reports, it looked like the biggest thing to me hanging out there is the status of your rocket motor. So can you give me an update on that?
Yeah, no, our motor design is in good shape. We static fired on March 26th. We have a little like slideshow and stuff later with some numbers in there, but yeah, the impulse was pretty much right on to what we were expecting, and the trace was pretty much exactly what I would expect it to be.
Have you provided the data to ESRA?
Was it in our last progress report?
This project report 3 is in it.
Yeah,
So-
not in 3.
Yeah, so it wasn't asked in progress report to supply any of that data, and there wasn't really a space, but if necessary, we can either email you that data or whoever needs it.
Yeah, email it to me. That's something that's important for us to have at ESRA. It's one of the things they want to have. Did you guys collect pressure and thrust or just pressure?
Yeah, pressure and thrust.
Okay, fantastic. And just real quick, so since I know you'll send me the data, but what were the total impulse and what was the peak pressure on that?
The total impulse was like 77.25, I want to say, Newton seconds, and the peak pressure was around 800 to 900. I would have to look at the trace.
Okay. Anything funny in the data? Any pressure spikes or anything like that?
No like spikes or anything. It didn't look like there's like a little bit of a bump in one place, but nothing major. We usually do a little bit of a burst disc on the front end before firing, and that didn't work out super well. So our startup was a little slower than I like to see, but the trace it seemed to be the grains were quality.
Okay. Are you planning on using a burst disc at ESR at the actual competition?
So I always use the terminology burst disc. It's really just some HVAC tape. And yes, we've always done that though.
Well, I asked because are you going to be using head-in ignition or traditional up the throat?
Up the throat.
Okay, cool.
Yeah,
that's really I was getting
you
after.
just slip the wire up and then tape it over.
Okay, fantastic. And so it looks like you have it right there.
Yeah, here's the case is right here and the closures as well. So
Okay.
This is the graphite nozzle, and this is the bulkhead. This is the one that we made for just the static fire. So it's got a center post there to put the bolt for the load cell, and then a port for the transducer. But there's going to be a slightly different bulkhead. The interface is the same.
Okay, awesome. And did you guys manufacture that, or did you have that made by? It looks like it might be Mike Fisher, or
no. This is designed and manufactured by us.
Okay, is it a snap ring or is it a snap ring? Okay.
Yeah, we use
not Frankenstein. Okay, very good. So yeah, the big thing just so you just give me the data from your test so I can review it and make sure you're good to go with the competition. And then are you planning on doing another one? Because it looked like you had one planned for May in the report.
Yeah, so we initially had planned to do a test flight, and we prepared an identical motor for that. Now that we're not doing the test flight anymore, we have this motor made, and I still think that we should do a little bit of adjusting before competition. So for this one that we have, I think we might actually static fire again, just to get more data, and also to see if there's like a notable difference when the burst disc is done better, to see if it really like does do anything or if we're just crazy.
I don't see many of those, but okay. So the only thing that you would be adjusting is that burst disc. There's nothing else that you'd be making any major changes to the design of the motor.
Definitely no major changes. We might just like adjust the port diameters a little bit, if we want to gets plus or minus some impulse.
Okay. Yeah, just be careful on those. You know,
Yeah,
small
we're-
differences can make a big, small changes can make a big difference.
Yeah, we
and-
always like check for erosion problems and stuff, and we're definitely like pretty thorough with the bait screens.
Okay. Alrighty. Moving on. So you've got the motors, you've already got the motors manufactured and everything. The only other thing I wanted to just kind of make you guys aware of, and I didn't catch it, sorry I didn't catch this in your second report. I did read through it several times. You know, just be very careful when using the HX872. Did you end up using that, or did you end up going with 878?
Do you mean the 752?
Yes.
Okay. Yeah, we didn't. So on these 4-inch grains, we're actually not using any bonding agent. We initially had planned to look into that when they were at 6 inches, but with at the 4-inch scale, it's not super necessary. So
Right. Yeah, I would make sure you read the
I
MSDS.
appreciate that. We did have to actually buy some like an upgrade to our filters that we use with our respirators, but yeah, we
Well,
didn't
no,
end up
it's
actually
it's
using
not
it.
that. So it's so
skin
read the
exposure?
MSDS on that bonding agent. HX878 is fine. There's nothing wrong with it. It's not really dangerous, but the 752.
Yeah, no, we've read through the MSDS. It is scary.
Yeah. So what's the big one? So if you read through it, what's the big eye opener on
Skin
that one?
exposure, isn't it? Or I mean, just like effect wise.
It's
Yeah.
the respiratory skin effect.
Yeah,
Anything that can sublimate essentially into your bloodstream causes tremendous. Its reproductive harm is what they kind of
Bingo.
are about.
yeah,
that's
that's why
it.
I think you meant effect wise. If it was for the
Yeah.
mutagen.
You guys are young. You don't have families yet. I would just stay away from that stuff. Yeah, I'm military, so anything that looks or smells, you know, kind of like Agent Orange, look that one up if you don't know what that is. Yeah, it's bad stuff. So, okay, that's pretty much it. So that I had before we did a walkthrough. So do you actually have the rocket there with you?
We have the components going together, so you just want to start at the bottom and kind of work our way up.
Yeah, lower airframe. So you know, to start with like motor retention, shock cord retention, fin attachment, all that kind of good stuff, and then
Alright.
step up lower airframe,
So-
upper airframe, and nose cone, avionics bay.
Yeah, so basically everything, almost everything we've made this year has been SRAD. So our tubes is the big one for us this year. We've done hand layup fiberglass in the past, but we've gotten our X-winder system up and running, and it's producing great results. This
Good.
was made on our X-winder, fill and wound fiberglass, 48 inches long, and it's a beast. It's just from just qualitative testing, just like feeling it from the flight worthy hand laid fiberglass we've flown in the past. It's lighter, stiffer, just overall feels stronger. Not quite as brittle as the COTS stuff. It's a nice middle ground in between the two things we have that are flight proven. We're really happy with the results so far. So this is our booster section. As I said, 48 inches long. Inside that goes our motor mount system, which is not inside yet. Same deal. We wound our motor mount tube and then just have G10 fiberglass cut and centering rings with some big chunky fillets holding them in place. Motor retention is going to be Ford motor retention. We have that CAD all worked up. We're just made out of finals week, so we're getting on manufacturing that pretty soon. Did you want to talk a little bit about that?
Yeah, so in the past we've done kind of an Aeropack style. We call it our serial ball, where it just bolts to the airframe and then has a center connection.
Yeah, minimum diameter Aeropack.
Just from doing
Okay.
min-time. And we're definitely planning on doing that sort of style again. I kind of have dreams to make it some kind of composite piece, which I made a new version of the CAD recently for finals. It might end up being just machined out of aluminum. But either way, it's going to be like that style of art.
Okay, so you'll have almost like a screw eye
Mhm.
that you'll twist the motor in and it'll be secured there. And then your shock cord is going to be on that screw eye. So you will have
Yep.
direct connection between your shock cord and the motor itself. There won't be anything else that's holding
No.
all the motor in all by itself. Okay,
Yep.
that's good.
So we have that section, and then going up, Corey, you want to bring over some of the electronic stuff?
Well, so do you show me the fins? Do you guys have the fins yet?
Yeah. So we're in late stage manufacturing of them. So right now, so we're going with four fin design. Right now, this is just the bare bones section of it. So what we did was we have a 16th inch fiberglass spar going through it, and then we have carbon fiber nylon 3D printed ribs that you might be able to see going through there to give it shape. And then we set it into a two-piece mold we made, filled it up with high density expanding foam, and probably it's going to happen this weekend is we're going to do 4 layers of carbon fiber cloth, just overlay on top of it and vacuum bagged, give it strength. We're doing, as you can see, no fin tabs. Even though we're doing a 98 millimeter motor and a 6-inch rocket, we're still doing surface mount because I don't like the idea of large gouges going inside these homemade tubes. So surface mount, just tack it on, fill it, and then lots of tip to tip. So probably 4 layers of carbon fiber is our usual, with starting with a big section, then descending to smaller cross-sectional areas.
Okay,
But,
what is your fillet material going to be?
we use just US composites, probably using medium cure. And then we have filler that goes inside.
Just straight epoxy wood filler.
Yeah, straight epoxy with filler. We've used that in the past and have never had.
Well, what filler though?
It's
406 colloidal silicate.
yeah, 406.
Okay. Yeah,
So-
that's the answer I was hoping for.
Yeah, so that's why we've had success in the past, because we've used that. But
Yeah.
So those are all surface mount.
When I do mine, I would just say, in having done that quite a bit, just make sure you rough up and then clean your
Yes.
bonding surfaces. And if you can, so typically what I do is I'll tack them. So with like a 5-minute epoxy just to keep them in
Yep.
place to make sure that they look good. And then the next day I'll come back and I'll lay in the fillets and lay up because you'll get, what will happen is to get a chemical bond on that fillet instead of just a physical bond really increases your strength right
Oh,
there.
so
And
you
that's
do-
usually where it breaks. Yeah.
Cool. Well, that's
Yeah,
something.
I'll lay it up and I'll even take, like, once I lay it up, I'll take like a piece of like a 1.5-inch PVC pipe,
Mhm.
just the thing, and I'll use the edge, the round edge of that to draw my fillet.
Yeah,
Instead of-
the Jim Jarvis method.
Yeah, it works.
Yeah, it works great. So yeah, those are being tacked on. So
And then just be careful when you're doing with carbon fiber. Don't,
yes,
it's
we'll get-
respirators, do it outside, hoods,
Yep.
the whole 9 yards.
yeah, for sure.
Y'all are too young to get that crap in your lungs.
So one of the few, like moving on, one of the few components that we are going COTS is we have COTS couplers, just because it was hard enough finding a mandrel that had a 6-inch OD. I didn't even look for this stuff. It would be impossible. Plus, most of our bending loads are going to be on these.
Yeah. How's the fit?
Just found out that it was this good like 5 minutes ago.
Oh, very good.
Yeah.
Perfect. That's great. That's
Yeah,
really
we
great.
just use PML phenolic coupler tubes, and those go great. I managed one time, I don't know how I did it. I managed one time after we wound to pull out the cardboard and reuse the mandrel. Every other time since then, it's been epoxied and we just have to destroy it to get it out.
Yep.
It's a fine line.
Yeah.
So
But,
I looking at your open rocket, I see a boat tail on your design. Is that
was-
still in
yeah,
place?
that was an older one that we submitted with Progress Report 2. We were originally going to try to wind a boat tail because the software we have can do non-cylindrical geometry as well. We just decided, just because, I mean, obviously our rocket's not entirely together, we decided to focus. Yeah, we decided to table that idea for next year probably.
Okay.
So yeah, no boat tail. I think that should be the only thing that changed.
We can also supply a new version of the Open Rocket and
Yeah.
our CAD designs as well, in addition to the motor data, if you would like that as well to oversee.
Sure. Yeah, send that with the motor data. That'd be great.
So inside
And then what about launch lugs for the lower airframe?
we're going with surface mounted ones like we've always done. We get them same material as the ribs for the fins. We do carbon fiber reinforced nylon 3D prints. We get them done at the university. We have airfoil launch lugs that get epoxy to the surface, and then we do small little tip to tip sections, kind of small overlays with carbon fiber to really hold it on. These things are like indestructible. You'd be surprised because like you hear 3D printing and you think, oh, it's gonna fail, but yeah, these suckers are tough. Yeah, yeah. We've never had an issue with them breaking, but
Awesome.
yeah, we'll have one located probably right around the aft centering ring, and then our next one will be up on the switch band most likely.
Okay. And then okay, yeah, let's move up to the airframe.
Yep. So
The upper airframe.
Upper airframe, same deal, wound on our X winder. This one's not as sanded down as the other one, so it's a bit shinier. We'll bring down the OD a little bit, but it's right where we need it to be. Same deal, wound fiberglass. And has same structural properties as the other tubes we made, right in the middle between the hand laid fiberglass and the Wildman tubes.
Okay.
Yeah, qualitative.
We're
Yeah.
planning to do like some destructive testing with sample pieces
Yeah, we have some small components and
to get some actual data behind it.
Yep.
Okay. Y'all have any like air vent holes in those tubes? So that
those are gonna come in afterwards, but yeah, we just to avoid like pressure separation, we'll drill properly sized vent holes, especially on around the switch band with all the electronics.
yeah, so that'll be necessary for like the to vent the gases in the avionics bay, but also to vent the gases in the upper and lower airframe
Yep.
as it ascends.
Yeah, we've seen a lot of other teams' rockets not know that you should have vent holes on places other where the electronics are, and that's never turned out good.
Okay, so as long as you guys know that, awesome.
Yep.
And then so talk to me about the avionics bay itself. How's it held into the upper airframe?
Right, Corey.
Okay, so this year I specifically wanted to work on kind of optimizing the amount of space we have available in the avionics bay. So I went ahead and made this new design that I don't think I've seen in any other like rocket of like our skill level. So instead of having a single like or vertically mounted sled, basically, we're gonna have 5 of these circular ones with like a twist locking mechanism. I don't know how hard or how easy it is to see because it's like clear polycarbonate.
Okay.
We have 5 of these that are going to be mounted with the steel arms that the like handle actuates, and they're going to be guided by these 2 rails that run the entire length and of the coupler that are tapped on both ends with M8 thread.
Okay.
And in terms of like how that's going to interact with our like recovery system, the forces should be identical to the old design, where it went through the U-bolt into the bulkhead and then down the
Two-threaded
down
rods
to
running the whole
a length of 2 threaded rods. So basically these serve the function of those 2 threaded rods, and the forces from the U-bolt to the wood and all of that is the same from the old design.
We
Okay,
have-
so it'll transfer to those 2 rods running the length.
Yeah.
Yeah.
We have
Okay.
a cat all of that set up too, if you want to see it at some point.
That's in our presentation as well,
Yeah.
that we have as a secondary, if we want to show anything more specifically on that.
Okay. Yeah, as long as it sounds like you've at least thought about the load transfer along those. I've seen several where the bulk has just break out and now you got a rocket coming down in 2 pieces. So at least as long as you guys are thinking about that and thinking about the load transfers, you know, I feel confident you guys got it.
Cool.
How are you preventing so the let's say the apogee charge goes off? How are you keeping gases from getting inside the avionics bay there?
We use like pretty pretty like close fitting, like tight tolerance bulkheads on either side. We never had to like go out of our way to seal it. We just make sure the tolerance is really small, and we've never had any issues with like just looking back on like pressure data and stuff. It's clear that nothing gets inside.
There have been some instances when we've noticed some discrepancies during deployment testing, in which case we just put a little bit of like weather sealant around where the bulkhead meshes. So then when we, lock in, it's like a seal fit. Once we get our deployment testing information, we'll have enough data to make that decision on if it's necessary. And our design does have provisions to include it if it's required.
Yeah.
Yeah,
Usually
so
it's
the
not-
reason I'm asking is because of the back and forth I've had with Gabriel on you guys' system. So if you guys have code in there that will look for and ignore those transients, that's fine. But if you have a momentary pressure spike inside the avionics space shortly after apogee, it could fool your student system into firing your mains right at
Yeah.
apogee.
Yeah. Well, I'm sure Gabe has been working on that, but yeah, that's something that's been on our radar.
Okay, but a proper seal and will help prevent some of that from happening.
Yeah. Well,
Gabe, do you want to add anything?
Yeah, so currently the plan for code right now is to do outlier detection, which would hopefully smooth out some of those random spikes. And I had detailed that to you in the email and everything. But we can also add a delay to apogee to ignore those transient spikes as well.
Okay, as long as you're accounting for them.
Yeah, I'll account for them. We're kind of working on the code as we speak, and we're planning on using some pressure data from previous launches. So hopefully we'll see those spikes in that data as well, and be able to program accordingly.
Good. That's what I was going to suggest. It's use some previous data to test your algorithms on whether or not they will, not get tripped up by that. Let me know if you need some data because I have plenty of those files.
Yeah, actually, if you have data that's ready to go, the more the merrier. The plan is to do some data collection here from Matteo had specified that he had some files as well that he could acquire for us. And we were going to add some synthetic noise there just to make it a really like worst case scenario type of situation. And then just run it as though, whatever that signal is being effectively played back through the same channel that the pressure sensor would interact with the teensy.
Okay. All right. Do you guys have, so how are you, can you walk me through your switches again? I know I've looked at it a few times. Let me bring it back up.
I haven't looked at the switches in a long time. Have they changed from like what I originally said?
Still continuing with the lab rat rocketry.
Okay.
Switching switches.
All right, so yeah, so switches haven't changed since the past reports. So we like to be real redundant when it comes to this. Since we're riding with 3 altimeters, our Telemega, our Stratologger, and then our Strata system. We're using the LabRat Rocketry triple pull pin switches, which we've used pull pin switches in other rockets, personal rockets. We've had great successes with them. Never an accidental arm or disarm. And then as a redundancy, we're going to wire 3 screw switches in parallel as well, just in case. So we have dissimilar redundancy on each channel. So say we get a bad switch from LabRat, which it's never happened, but just in case it does and we lose continuity, it's still going through that screw switch, which is basically as secure as you get when it comes to switches, having a physical thing inside. That's our plan. That's what we did for last year's rocket for competition, and worked great.
Okay. Yeah, I just brought your diagram back up. You actually have one of the better, more easy to understand diagrams that has been submitted that I've seen. So a lot less questions there. I got yours confused with one of the other teams. So, okay. And then, so you got the Telemega. Have you used the Telemega before?
Yes,
Oh, yeah.
we've used it extensively. Yes.
Okay.
Taylor can especially talk about that.
We know the ins and outs of a Telemega at this
Good.
point.
Good. Yeah, a lot of newbies, when they start using the telemega for the first time, they get a little bit overwhelmed. It's a bit of a complex system. So
Yeah, you were definitely right on with your comment in one of the emails, but yeah, we have a
the
great
maybe
experience.
My primary responsibility for the past 3 years has been to be a master of the Altus Metroman perfect flight altimeter system.
well, that just speaks to the complexity. You shouldn't need to be a master of it.
Yeah, honestly.
I have some choice words for Altus Metrum, but we make do.
Yeah.
Yep.
I mean,
Okay.
it's a strat logger too.
Yeah.
Yeah, I mean that's almost impossible to screw up.
Yep.
Okay, very good. And then just keep me in the loop on how if you need any help with the Astraeus. You know, it's a little bit concerning that you guys don't have all the coding done on that, and you're not going to be able to get a test flight. So if there's any, I would just say if there's any anomaly in your testing of the Astraeus, I would just, you know, fall back to a primary and a secondary, and then eliminate charges on your tertiary. The last thing you want is your tertiary one that student build messing you up at the competition.
That's our plan. Is it has to be best case scenario to award charges on the actual flight. But yeah, thanks for bringing that up. That's what we're doing.
We also do have the intention of doing maybe not a full scale 10K test flight of the Astraeus system, but I know Gabe and his colleague Sith are going to be trying to shoot for a like low altitude test flight around the May, June-ish mark if we're able to get to that point, so we can still have that proven flight data, whether it's on a personal rocket as opposed to the competition rocket. We're still hoping to go for that.
Or, I mean, honestly, if you guys just slingshot the thing a couple 100 feet in the air.
Actually, something better ideas. Maybe have a drone.
That would work too. Fly it up with a drone and drop it, or fly it up with a drone and bring it down with a drone. Don't drop it.
Yeah.
Antenna launcher.
Loaded up to
Yeah.
Do you believe that the data from a test like that would be sufficient enough to essentially prove its flight readiness?
Well, you're mostly I can't see your code, but it sounds like you're mostly using the barometric pressure sensor for event detection. If you're doing that, a drone is going to give you all the barometric data that you need.
Would the propellers not significantly affect?
The biggest thing that we would need to get is like you mentioned, the pressure spike if there's a inopportune seal, or not inopportune, just a non-ideal seal, or the biggest thing is the transonic pressure spike. Those are the two edge cases that we're looking for better ways to test, and at the moment the only ways that we can think of that are by running existing data through the system.
The only time I've seen that transonic flight regime mess up the altimeters is when you really have to go supersonic. You'll get a little bit of wiggle in the data, but it's not going to be enough to trip it. It's mostly what I've seen are big spikes when there's insufficient sealing of the avionics bay. That's what I'd be worried about. If you guys were going to 30,000 feet and Mach 2.5, then it would definitely be a concern. But you're not. You're going to 10,000 feet. You're going to be transonic at best. I'm a lot less worried about that tripping you up.
We're not going supersonic. We're like we're like bottom tier transonic.
Yeah, that's much less of a worry than the the charges going off in full in the system.
We're all just used to 30K.
Yeah.
Yep. Okay. So I'm good on that. Sounds like you guys got a good plan. I'm bringing them back up my list. You guys got a switch band, it sounds like.
Yep. We wound one of our tubes a lot larger than it needed to be, so we had some cut off. So wound a 2-inch switch band as well.
Good. Just make sure that thing is even on both sides, and it's secure in place. Should really go without saying. Talked about retention. Are you guys using charge wells? Were you one of the teams using the CO2 system with the black powder backup? Remind me.
So initially we were planning to utilize our Raptor CO2 system since we have previously utilized it in our 30K entries. However, with dropping down to 10K and after reconsidering our options, we've decided to go against using the CO2, and we're just going to fully operate on black powder charges this year.
How are you retaining that?
So what we do is we do the charge well system with E-matches. So we take about a PVC charge well is usually what we do on top of the bulkheads. Put the E-match in itself, pour the black powder on top of it, pack it in with dog barf, and then seal it.
Yep.
Yep.
Like
exactly.
this?
Exactly.
Okay, good.
With the
That's-
E-match then being wired to our electronics and avionics.
Yeah, and depending on how much black powder we're using, it dictates how much tape goes on the top. But
Yes.
for these larger ones, I think we're probably gonna be using about like 4 grams tops for
Yeah.
main separation.
We're looking to verify that through our deployment
Yep.
testing once the rocket is fully done and taking place. And my intention with recovery is to verify that prior to June 9th at the latest.
Okay. Just keep in mind that the behavior is going to be different at 10,000 feet than it
Yes.
is going to be at ground level. So
And
you're
that's why
gonna
we
need-
take so much effort in packing them nice and
Yeah.
tight.
Yeah,
Especially-
pack them tight,
especially
and then for the
ones.
apogee ones, make sure they're long. Have you read Jarvis's article about the length of those tubes?
Yes.
Okay, good. So you know to make them long for the apogee charge, because some of the powder may blow if you put it in the bottom, it may blow the powder out without igniting, and so your 6 gram charge turns into a 3 gram charge.
And then it's not enough to separate.
Yep.
I've seen enough student teams bringing in a rocket ballistic from 10,000 feet to not want to see it again.
Yep.
Yeah.
We're definitely going to avoid that at our best.
Yeah.
Okay. Very good. And how are you securing the wires? Is that with terminal blocks or, direct wiring, or how are you doing it?
Yeah, so last year we used speaker screw posts because I think
Okay.
that's what ESRA liked us to do. We've used terminal blocks in the past. Not entirely sure why they wanted us to switch it up, but we used it last year and it worked, and we're familiar with it, and we didn't see any issues with it. So we'll probably just use the screw posts again.
Yep, either is fine.
Yeah.
Very good. Okay, so talk to me about the nose cone.
So one of the only other COTS pieces is 36.5-inch Wildman von Karman.
Love it.
Yep. We were gonna try to wind it like months ago, and then the tubes took so long to figure out, and yeah, that's my ultimate goal, because I'm the guy who made all the tubes. That's my personal goal for next year, is to have all of our tubes made and have a nose cone wound in-house. I feel like that'd be awesome. But yeah, so just straight COTS, nothing special about it.
Okay, the shoulder on that looked a little short. Is it just because it's deep
Yeah,
down
it's
in
just
there?
because it's really stuck up inside. It's yeah, I think it's a 9-inch shoulder. So yeah, we'll have 6 inches overhang for to meet that caliber requirement.
That's plenty sufficient. So based on the last open rocket that I see, it looks like your payload's going in that.
Yep, it'll be
Is the
up
payload
inside.
plan still the same?
Yep, no, nothing's changed with that.
How's the development of that system coming along?
The frame of the hardware is in good shape. It's right here. I think is Michael.
Yeah,
Yeah.
Michael's on.
You were the ones who were wanting to do some data collection system for a CFD type system, or am I thinking it's another team?
No, you're right
That's
on.
us. Yeah, we'll have pressure taps running mostly just confined to the nose cone and upper airframe section, but we'll have pressure taps through the airframe, gathering data as we go up.
Okay. And then, so do you think you'll have that done in time, or are you gonna have to switch back to a dummy payload?
I think we're gonna be just fine.
Yeah, we're on track.
Yeah, like we're basically at just assembling everything now. We've got all of our components manufactured, and just now that finals week is finally over, we're just putting everything together.
We also have a secondary scientific payload that will also be flying on board that another one of our members has worked on and flown on his own personal rocket. So in addition to the Torricelli CFD pressure profile item, if that is unable for unforeseen circumstances to not fly, we will have a secondary scientific payload ready to fly as well on board.
Okay, roger
There'll be
that.
science either way.
Yes.
Okay. And then have you guys thought, I couldn't tell from the open rocket, but how is that going to be retained? So it's a big mass that you're going to have sitting up in the nose cone. You're going to need to have some way of retaining that thing without it having to without it tearing free. You'll be pulling some G's. So
Yeah, so-
talk to me about that.
Our current plan with how it sits right now, which might change slightly, but most likely won't. We'll have a bulkhead epoxied inside the shoulder that goes into the nose cone. The shoulder won't be epoxied to the nose cone itself. Payload will be mounted inside to that bulkhead, so kind of just be sitting inside the coupler, and then we'll have composite friendly flange nuts epoxy to the inside of the coupler that will screw in through the actual body of the nose cone, just some countersunk holes, so that we can actually remove the whole system and put it back in and then all of the load is transferred just to the payload itself. So we don't have an 8-pound payload whipping around, pulling on everything. The only loads that will be transferred into that system is just the inertia of the nose cone mass itself.
Okay, so it's going to be in the shoulder.
Yep.
But the shoulder is not going to be. How is the shoulder connected to the nose cone again?
Yeah, so there'll be radial bolts that go through the actual body of the nose cone, through the body of the coupler, into nuts that are epoxied on the inside. Yeah.
Okay.
We have a smaller rocket where we've done this. We're bringing it around to help visualize this a little bit better. So
I see what you're saying. My only concern would be there's going to be a lot of force on those bolts. How many are you planning on using?
4 minimum. How we have it set up, there won't the mass of the payload won't be transferred to those screws. It would just be the mass of the nose cone itself. It's a whole entirely separate system. So do you want to talk about this at all?
I was just going to mention, so the idea is the actual structural part of the rocket where recovery and the payload attaches to will be the shoulder, and then the actual nose cone shape will just be almost a shroud that slides over and gets bolted on.
Yep.
So the only thing that the screws have to retain is going to be after drogue separation, after main separation, because during ascent, the nose cone, the actual profile of it will be pressed up against the main airframe. So so we're effectively just using the nose cone shape as a shroud that only has to support the weight of itself, and the actual hard point is within the coupler itself.
Yeah, the recovery hard point is attached to the payload. 10 his radio setup is our payload. The eyeball at the bottom is connected to that, and then the screw is just simply holding the nose cone on to that entire system. So
So here would be my concern, and my only thing I would say you guys review. So big rocket, big payload, big mass. It's going to be accelerating at what, 10 Gs? So those 4 bolts are going to be holding all that mass that's in the coupler. Okay.
Yeah.
They could tear through beyond ascent. So when we were building our 40,000 foot shot for one of my other teams, the acceleration, just because the avionics bay was in that shoulder, was enough to where it gave us concern. So what we did is we put a second band, kind of like a switch band, around the shoulder of the coupler of the nose, so that it would support the weight. So the load is transferred directly to the airframe and through that band instead of 4 bolts.
Yeah,
Does that make sense?
Yeah, that's
Yeah,
you can do that.
So it's funny you mentioned that, and it completely aligned. That's actually what we did on last year's Spaceport rocket, because we had a fully deployable payload system, and the way that the recovery worked was a bit more complicated, and I totally blanked. What we did on that rocket is not only did we up our shear pins from number 4s to number 6s, but we also had a band, like you mentioned, that was epoxied on the inside of the main bay to support that coupler during ascent. I totally blanked on that.
Yeah, you mean an exterior band to the
Yes, kind of like your switch band. Because what I'd be concerned about is on acceleration, it would be those 4 screws on liftoff that are holding up your payload, and if those fail, your coupler is going to slide down into your main tube, and then there's nothing holding on your nose cone, so then that comes off.
We'll definitely review that, because that's how we held our payload, and we had an internal, just a small cut off of a coupler, epoxied roughly where like epoxied inside the airframe where that was located the maximum like depth that our coupler that held the payload on went.
Yeah, like a shelf.
Yeah, so it was just a little shelf on the inside that
Oh.
was just we've done
That could do it too.
Yeah.
So there's a bunch of ways to skin the cat. My only concern would be, you maybe 4 little screws may be insufficient to hold all that weight during acceleration and liftoff. So just take a look at that. That's the only thing I would suggest, because I would hate for you to get all the way out there and then your payload slid down and your nose cone fell off because 4 little screws failed.
Yeah, we'll definitely do that. That's
Okay, very good. So it sounds like you guys have talked about shear pins. You talked about the main. How are you guys retaining and protecting the main chute and the drogues?
So primarily, this year we're utilizing a main chute from Fruity Chutes. It's going to be an 8-foot diameter one. And what we do with that is we utilize Fruity Chutes deployment bag as well. So that'll be what houses the deployment bag itself. And then we also do a secondary protection of wrapping that and part of the recovery harness into a Nomex blanket, in a way of like a burrito style, like you would at Chipotle. We do a really good packing for like dry run of deployment testing. We do it the night before at competition, make sure it's not too tight in the airframe so it has room to slide out and then also unfold itself as well. And then for the drogue, we're using a classic 2 sky angle 28-inch diameter drogue chute. And with that, instead of using the Fruity Chute deployment bag, we're just going to make sure we wrap it up a couple more times in the burrito style and the Nomex to protect it.
Okay, as long as you're thinking about that.
Yes.
And then
we'll probably
go ahead.
also have a not Kevlar, a Nomex sleeve that goes on the bottom portion of our recovery harness as well.
Yeah.
We'll probably have that.
We have 2 of those that go on both the drogue recovery harness and the main recovery harness in the points where it's most optimal. Well, not really optimal, but
where it needs
the
to be.
biggest chance
Where
for it
it's
to experience any type of burn from the deployment charge.
Is that because it's nylon?
Yes.
Okay,
We
and it's
use
like
it-
1-inch tubular.
Yes, that's what we use.
Okay, yeah, that's what I thought. I thought I remembered from your report. Okay, very good. The only thing I would just say to remember is when you're using those Nomex blankets, it's a good practice to kind of zip tie those farther down your shock cord so that when your shock cord comes tight, it pulls the blanket off of your parachute. So look at the lengths of all those cords and actually physically see how it would separate. Because sometimes I've seen where you wrap it up like a burrito, and because nothing is pulling that burrito off the parachute, it comes down and it never deploys.
Yep.
We fold and unfold and refold and add baby powder and fold it back.
So like,
But certainly.
Very good. Good. As long as you're thinking about it.
yes.
Okay. We've talked about the nose. We've talked about the upper airframe. We talked about the avionics bay. Oh, how is the upper airframe held into the avionics bay?
We have as you said, it is held in. We're gonna have, I believe, I think 12 total screws going through the upper airframe into the coupler and then meeting inside those long aluminum rails that
Okay.
So just standard screw. That's how we're holding it in place.
Okay. Perfect. As long as you're thinking about it, it sounds like you've got a plan to hold it in place. It doesn't need much because it's just has to hold it in place for separation.
You need your parachutes to shoot out like a cannon, not the other way around.
You got it. Okay. So we talked about the nose, the upper airframe, the avionics bay, the lower airframe, motor retention, all that kind of good stuff. So, other than the fact that you guys got a lot of work to do still,
Yes.
you do have some time. So you guys have transportation. How are you getting out there?
So, obviously with our SRAD propulsion system, hazmat shipping is gravely expensive, and taking 14 students and our faculty advisor out there, flights are also expensive. So we make the 27-hour drive in a university van and then a rental vehicle where we just make the trek. A couple of our students will be joining us out there via flights due to internships and stuff. So once we all drive out there, we will pick them up at the El Paso airport and head to our location in Las Cruces where we'll be staying.
Good. As long as your answer was in my checked luggage. Wasn't that?
We're gonna sneak
Yeah.
it in.
No, we just avoid the hassle of trying to fly with it. It raises a lot of eyebrows whenever it's an aluminum pipe loaded with a bunch of APCP. So we'd like to avoid that as much as possible, getting on a watch list.
Yeah, they wouldn't allow it.
Yeah, they wouldn't put us on a list. They just get us.
Okay, very good. Okay, that's pretty much all I had for you guys. You guys have any questions for me?
I don't really think so. That's everything.
I don't think we've gotten progress report 2 feedback.
Oh, yeah.
I know we've already pretty much passed everything and probably some of it's covered tonight, but
Feedback now.
would it be possible to have any of those comments?
Sure, I can give you some. I mostly looked over your stuff, compared it to what you guys did in the first one. And I had some back and forth with Gabriel for a couple weeks there. So I'm sorry I didn't provide anything official, but I can do that if you really want it.
Not an issue. I was under the impression that it was just sent into a spam and it got lost in spam.
No, I got it. Sorry. I failed to communicate. That's me.
That's fine. I think. Can't think of anything else. Yeah.
Okay. So just reach out if you guys need any questions or any advice or you hit any hiccups or roadblocks. Okay.
All right.
And then if you could stop the recording and then find a way to get it out to Andy, the VP, or just send me the link and I'll do it. However you guys want to do that.
Beautiful.
Sounds good.
Okay.
Thank you.
Yeah.
All right.
Thank you.
Good luck, team.
Thank you.
Thank you.